So let's do this. We're going to do a deep dive today into Google Zanzibar and how you can use it for authorization scenarios. This talk is mainly aimed at developers and architects implementing authorization in their systems. My name is Damian Schenkelman. I'm a principal architect at Auth0, a product unit of Okta, and I spent a lot of time last year thinking about authorization, how to make it easy for developers implementing authorization, and we ended up implementing both a SaaS and an open source product inspired by Google Zanzibar. Now, what we're going to do today is we're going to go over a background of authorization, then we're going to get intro to Zanzibar, understand what it is, why it was created, then how it works, how you can get started with it, and when you should be using it. So let's kind of like do a quick recap of authorization. Authorization is not authentication. Authentication, who you are, authorization, what you can do. And when you think about developer requirements for authorization at scale, these are the 5 that I think about. I should be able to easily review who has access to what. I should be able to do controlled change management, right? Figure out my processes, figure out who should be changing these permissions. It should be very explicit when I'm doing so. I should be able to audit what happened in the system, essentially who accessed what, when they did it, why they had the ability to do that, and so on. And finally, 2 things that I don't think are very often thought about are reliability and scale. If you're building systems, you typically need authorization to be fast and reliable, because authorization is something that happens on every request. If authorization is not working, your system is not working. If authorization is slow, your system is slow. That means a bad UX, that means losing revenue. We don't want to lose revenue, that's not a good thing. So how do we typically start? What are the typical approaches to authorization? Well, the most common one is RBAC, or role-based access control. What a user can do depends on what their role is. This is very common, standard, and the thing here is that RBAC typically is 1 role per application, right? Or a few roles per application. And that's very granular. Imagine if you had a picture viewer role on Instagram that allowed you to view pictures, but you would be able to view everyone's picture. That's not good. It's very coarse-grained. You typically need more finer-grained control there. If you try to do finer-grained control with roles, what you end up with is typically role explosion. So I can be a picture viewer for friend A or a picture viewer for friend B, and that ends up with lots and lots of roles. And if you're doing authorization and embedding that data into mechanisms like access tokens, you get token bloat, these very large tokens that don't get through proxies, and then the IT team calls up and says, hey, why are you sending 2 megabytes on the payload? Again, not a good thing. So the next thing is ABAC. And ABAC is attribute-based access control. That's when we take attributes from the user or the subject, we take attributes from the object, and the action that the subject wants to perform on the object, we take into consideration the context of the request. For example, the time of day, the IP address that originated from it, and essentially, and this is conceptual, we run a function that returns a decision. We either allow the action, we deny the action, and there might be other things that we want to do. For example, we might require step-up authentication. Now, when we think about ABAC, let's kind of like dive a bit back here. This is the typical architecture, right? And again, it's a bit complex, but these are the pieces of it. So first of all, when a user tries to view a record, in this case 1 to 3, the request comes in, goes to what's known as a policy enforcement point, and that essentially enforces the yes or no access decision. But it doesn't make the decision, it forwards the request over to a PDP, the policy decision point. It's the one that actually runs this code snippet, this function that we talked about, and the one that says yes or no, and that's the one that takes the inputs. Policies are deployed to these decision points, and they are authored in a policy authoring point, the PAP. And the PAP allows us to do kind of like this change management stuff. You make the changes, you make sure that they go through change management that you deploy. And finally, we have PIPs. PIPs are policy information points. That's where you get data that you did not have as part of the request, right? For example, you might have data about the subject because it's part of like the request access token, but you might not typically have data about the object, so you need to go fetch it from a database. And if we go back to those requirements that we started from, we get the first 3. We get access review, because we can go check the policies. They're separate from our code. We don't have it embedded in if statements everywhere, so we don't need to check every PR to see if any line change authorization logic. We can do change management because we have that kind of like encapsulated in the PAP. And we can do auditability because we can take logs from the PDP, for example, from the PEP and say, hey, this happened, this is why it happened, and so on. There's a problem though. if we think about how we develop applications as we grow especially, PIPs are everywhere, right? We do microservices. We do service-oriented architecture. We have lots of data sources, which means that if one of them is low or one of them is down, authorization can be down. That's not a good thing. That's not typically how we design systems. We try to make it so that the most critical components are up and everything else can be lower cost, so it might have less nines of reliability. You don't want to build all of your databases, all of your PIPs, with the same reliability and latency requirements as your authorization logic and your authorization service. And this is where Zanzibar comes in. Zanzibar is Google's internal service for authorization, and they published a paper about it in 2020. And they use that for all of these services: cloud, maps, photos, Drive, YouTube, and, if you remember, Google+. It's very interesting. If Google uses it, it means scale. And scale has kind of like two dimensions here. On the one side, requests per second, like how many transactions can it do? It works. Like they thought about it so that it works. But also, it means that all of these teams have lots of developers, and it means developer scale. This is a system that should be easy for developers to understand and change. And this is also something that they were looking for while designing the system. And then we have another thing, which is that it's very flexible. All of these products are very different, and they just designed this one system, one model to do authorization, and it works for all of those. So we thought, hey, this might be a good idea to abstract authorization for many other use cases. And the way we think about it is database as a service kind of like handles your data. It runs the database, but it has no idea what authorization is. Policies are extremely flexible. You can write anything you want, almost to incomplete languages in some cases, but they have no idea about the data. They have to go fetch it from somewhere else. Some of these have caches, but again, caches are hard, naming, another hard problem. And then Zanzibar, for us, kind of like sits in the middle. This is the mindset that we have. It's kind of like an authorization service. It handles your data, and it knows about authorization. And unlike what we saw before, it's based on relationship-based access control. What you get access to is not based on your role. It's not based on the attributes. It's based on the relationship between the subject and the object. For example, and let's think about a case we're familiar with, which is Google Drive. I can view a file if I am the viewer of the file's parent folder, okay? There are two relationships there. I am a viewer of the parent folder, and the folder is a parent of the file. I can do that because the authorization model says so, and the data says so I can get access. Now, what we're doing is we're rephrasing the question. We're saying, rather than can the subject perform action on the object, we're going to, does the user, because this is the parlance that Zanzibar uses, have relationship to the object? Again, it's very similar, but this is kind of like how Zanzibar phrases the question. And specifically from, again, a coding perspective, we're getting kind of like down to the API and developer orientation approach. What you do is you check that the user, in this case Anne, has a relationship, in this case viewer, with the document, in this case the object, in this case a roadmap. And the response is true or false. Now, how do you get to those answers? How does this work? OK, we're in for a deep dive. Hopefully we will emerge sanely after this, so let's go in. The first thing that Zanzibar introduces is the concept of namespaces. You can think of namespaces as your authorization model. Namespaces define the types of object in your system, similar to classes, and the relations that those objects have to users and to other objects. For example, a document in Google Drive has owner, like the person that created it, you can go change it. It has editors, and it has viewers. And one interesting thing, and this is very complex syntax from my perspective, but this is the syntax that the paper explains, is that to figure out who has a relationship to an object, Zanzibar uses set operations. What are sets? Well, you essentially take the set of users, in this case, that are related to the document as an editor. That's a set of users, a group of users, non-repeatable. Let's say you have all of those IDs. You also take the set of users that are related to the document as an owner. That's the second line there. And you union them together. That's kind of like line 06. And you get another set. And then if the user belongs to that set, then they have the relationship. So again, this is understandable, but a bit complex. There is a better way to explain this, and this is kind of like one of the things that we spend a lot of time on, which is how do we translate what's on the left, which is exactly the same code we had in the previous slide, to what we have on the right. So we are the developers, we are more often thinking about Boolean operators. So line 2 there is line 3 here. The owner is anyone that's an owner. Self is a special keyword. The editor is anyone that's an editor, self, or an owner. And the viewer is anyone that's a viewer or an editor. So again, hopefully you can see the parallel. Hopefully you agree that the one on the right is better. If you don't, come talk to me afterwards. And the second thing we do is we put tuples in the system. Tuples are your authorization facts, and they are triples. They have a user, a relation, and an object. In this case, we are creating the tuple Anne is a viewer of the document roadmap, and we have the same model we did before. So we can now ask the question, hey, is Anne an editor of the document roadmap? The answer is false, because she's a viewer. Right? So if I ask editor, editor is anyone that's an editor or an owner. She's neither, false. If I ask about viewer, true. Okay? This is kind of like, again, Zanzibar 101. Tuples, authorization model, or the namespaces, checks. Those are the 3 things that you do. Now, what about groups? What about sets of users? And this is kind of like one of the nice things about Zanzibar. I can go define another type of object in my system called a group, and I can say they have members. And then I create a tuple that says that Beth is a member of group A. Okay? So we're saying there's a relation there. And there's also a relationship between all members of group A, and they are editors of the document roadmap. That's special syntax. That's like, again, hashtag pound, I don't know, depending on whether you're from the US or British, but that's how it works. That's it. Then I can ask, hey, is Beth an editor of the document roadmap? The answer is true. Why? Beth is a member of the group, and group's members are editors. Editors are anyone that's an editor, we're good. And then we can also go ask, hey, is Beth a viewer? And the answer is true as well, because viewer is defined as anyone that's a viewer or an editor because she's an editor, she's a viewer. So we have 2 things here, concentric relationships and groups. We're missing one thing that we talked about while I introduced RBAC, relationship-based access control, which is relationships between objects. It gets a bit more complex, but here essentially we have that anyone that's a viewer is now also considered the viewer, the editor, or a viewer from the parent folder. Again, the original example we gave. We add a document type parent relation here. So we say documents have a parent. And then at the bottom, we say, hey, folders are a thing, and they have viewers. What do we do now? We create folder as a parent of the document, one relation. Another relationship, Chris, a user, is a viewer of the folder. And then we go back to the original example. Chris is a viewer of the document roadmap? Yes, because Chris is a viewer of the folder. Viewers of the folder that have a child item or a parent can see everything in the folder. Again, the authorization model says what happens. The tuples or the data says what's happening in the system, and you update the tuples as users make changes to your application, right? They go to the UI, they change who has permissions. So this is kind of like very good for sharing privacy and collaboration. Now, again, let's stop here. We saw how this works. Let's pause for a bit. That was kind of like the deep dive. But the problem is we're going to immerse even more. Because we started with, hey, the problem is reliability and latency. We haven't talked about that. Well, first of all, the amount of things that you can do with this is huge, but it's not everything, right? This is not a Turing complete language. The number of queries that you can perform is very reduced. It's just one check. And then the number of things that you can express is defined by the grammar of the language, which is not infinitely possible. But also, and this is where it gets good, this is what Google Zanzibar does. First of all, they use Google Spanner. You can think of Google Spanner as a database that runs distributed. Again, you can have multiple copies of the data. It's partitioned and sharded. But you can think of it as if it was one database running on one machine. So all of the properties that you might have learned about, like ACID and those things, are held there. Again, this makes it very easy for developers to think about it when coding against Google Spanner. But this means that you can collocate the data and your authorization model with the clients, with the YouTubes, with the maps and stuff, which reduces latency because of like speed of light stuff. Then they do a distributed cache so that you don't have to go to the database for each of these queries. Some of them are repeated. They route you to the one that's closest. They have a special index for deep group nesting, so that if you have groups of groups of groups, that's easily resolved rather than having to go all the way in. And finally, they solve a problem that few people think or even talk about when they think about authorization, but it's critical, which is search with permissions. One thing is point access. Can one person get access to one document, one object? That's what this solves, that's what policies solve. Even RBAC solves some of that. But if you need to figure out all of the documents that a user has access to that match a specific filter, think about how you would do that with a policy. It's very hard. You have to get all of them, and you have to make them go through the policy. If you need paging or sorting, you're screwed. Zanzibar has a reverse indexable grammar, which means that the things that you can express also allow you to calculate anything that you need for search with permissions. So give me everyone that has access to a document, or give me all of the documents a person has access to that match a filter. And also, it has a watch capability where you can fetch changes that are happening so that you can get those things into your Elasticsearch of preference and make sure that you have search with permission-like capabilities. Now, if you're interested in this, if you think, hey, like this might be interested, how do I get started? Well, there are a few options. Auth0 has a SaaS option, and we recently open sourced OpenFGA. So like, again, you have two flavors there. There's another company called Auth0. They have a SaaS option. I think the product is called Auth0. And then the open source version is SpiceDB. All of those open source things are on GitHub. And then there's another company, Ori, and they open source a system called Keto, also on GitHub. So all of these are different flavors. They all target different databases. They have different properties because they're inspired by Zanzibar, but not exactly Zanzibar. None of us are Google. You might want to check those out. And then what I recommend is to do this. Define your authorization model and figure out if it fits with the way of thinking that Zanzibar provides. You can also use some of the SaaS features, or even there are open playgrounds where you can write assertions to say, hey, these are things that I want to hold true for a while I make changes and iterate, and I can continuously run them. So that allows you to change your model, change your tuples, make sure things are working, and make sure that you're not breaking anything. If you're actually thinking of going kind of like all the way, start with shadow writes and shadow reads. Send data to the database, read data from the database, make sure that, again, it's working the way you intended it to work, but don't show that to users first. Make sure that you're logging those results and so on. Having the data in the database allows you to test at scale for those latency requirements that we talked about. So again, that's another win. And finally, if you're already using policies, but you want to enable some of these kind of like sharing, privacy enabling mechanisms, you can do that, right? Like Zanzibar, or your Zanzibar implementation of choice, can become a very large collaborative PIP, and you can just call to it from any of your policies. After that, again, ship it, and yeah, it's fine. So when should I use this? Well, there are companies like Airbnb and Carta, and they actually created their own implementations. They are not using any of the ones that I mentioned before. They created them before any of them were open and available, and they like it. And the main reason why they did it is it allows many teams to use a single system. Again, they think about the latency, they think about the consistency, but also as they add new features, it's very easy for those teams to make changes and know that things are working. Again, you can do progressive rollouts because all of this is kind of like API-driven. Generally, Zanzibar, the way I think about it, it enables secure, privacy-friendly sharing and collaboration. And remember, privacy is not about sharing nothing. It's about being very picky about what and who you share things with. And finally, it's generally useful in B2B or B2C scenarios. Now, things to look for, like, hey, I'm not sure if it's for me. Well, if you need flexibility for features as like your teams are building and you're shipping new things, but you need authorization, this might be a good thing. If you need low latency and reliability, that might be a kind of like another starting point. If your authorization data is granular, again, it does not fit in a token, and it changes very often, this might be a good fit. And finally, if you need to solve search with permissions. And remember, you will not think you need to solve search with permissions because your product manager does not know that they need to solve search with permissions, but you will need to solve search with permissions. Otherwise, it's not very useful as a product. Thanks. I hope this was useful. I think we have some time for questions. But again, I really appreciate you hearing me out. Thank you. Yes, and we have 5 minutes for questions. Vittorio would be proud. Yes?
What are some of the use cases where this will not fit in
So let's see. Yes. What are some of the use cases where this would not fit in well? The main use cases where this would not fit in well is when you have transitionary or contextual data that's required as part of authorization. So I'm going to give you the counter example and then how you might also do this. If you need kind of like, hey, IP-based access things, IPs are not kind of like something that you can easily relate to. Time-based authorization might not be another one of those. The good thing, though, is that there's a feature, again, it's part of Zanzibar. Some implementations have it. I will not say which ones. You have to read the doc. Otherwise, it might be product placement. But essentially, you can send tuples as part of the check request that are only evaluated for that request and not others. And that essentially allows you to deal with a lot of these attribute-based access control use cases. Make sense? OK, cool. Other questions? I think someone had raised. Yeah. OK, so the question is, it seems that underneath the covers, there might be a graph to figure out the relationships. Should we worry about like the graph size, the graph nesting, and generally like total like number of the complexity of the graph? If you think about like some of the very nice algorithms with like people from like European country names. So the good thing is that you don't need a real graph to express a graph, right? Like there is no graph database under any of these things. It's just a SQL. And the reason why the system can do that, and this is again Zanzibar and all of the implementations, is because the vocabulary, the grammar is limited enough that you know all of the possible queries that are going to happen, all of them. So you can index them very easily. And again, the good thing about like SQL databases and other databases that have been around for a while, in my opinion, is that you know the failure modes that they have. Graph databases have failure modes that I have no idea what they are, and I don't know if they know. That's kind of like a more complex question. So once you know all of the queries, then the question is like, how often do you have to do them? And that's where like the nested groups case comes in. Because it's just, hey, it's always the same queries. And then the worst thing that can happen is you have to kind of like keep going either through hierarchies of objects like parent, parent, parent folder, or group of group of group of group. And that's where that separate index, what they call it leopard, comes in, which essentially is like a couple of lookups to a couple of tables, and they kind of like flatten the whole thing, and you have like 2 requests and maybe 1 round trip to get the response. Other questions? Yes?
So how easy is it for us to establish exceptions to tuples or relationships that have been established?
OK, so the question is, how easy is it to establish exceptions to tuples? What do you mean by an exception?
Exceptions in the sense, I have a relationship that's been defined.
Yep.
It gives access to everybody in this group.
Yep.
To these docs.
Yes.
Right in this folder. But I want to create an exception.
I understand. OK.
On this one document.
Yes. So the question is essentially, how do I make exceptions that say like everyone in the group gets access to a document, but not this one document? So there are 2 ways to do that. First of all, there are 2 operators that I didn't show. All of the things that we did were with like or operators, so one or the other. You can do and you can do but not. So that's kind of like group exclusion. So you can say everyone that meets these conditions, but not these conditions, or everyone that is in this group or not in this group. And that's what allows you to express some of these things at the authorization model level. That has benefits. It also has trade-offs, which means it's like fairly static. You shouldn't be changing your authorization model every time you kind of like have lunch or stuff. The alternative is to do that with tuples. So essentially, you can create kind of like another group, and then like the more granular group has access, the other one is a parent, like, and things like that. So depending on how much flexibility you need, and depending on whether this is something that your users should decide, like if your users need to decide this, tuples. If you decide for everyone, authorization model. Wait 1 sec. We're on time. Maybe one last question, and that's it. If there are no more questions, I will be. Oh, yeah, there we go. Yes.
Do you know of any implementations that you could apply Zanzibar in an application with a legacy, say,
So the question is, can you use Zanzibar with a relational database? Is the relational database the one for search, or is, okay. Yeah, so at Auth0, and now I can talk from experience, we use Postgres for search. We use the full text search capabilities and a couple of tricks, but yeah. Yes, essentially, and the key would be that as tuple changes happen in the system, you essentially watch those changes. And you have a process on your side, because you kind of you know your tables, to take those changes and do kind of the join in another Postgres table. What that will give you is essentially your full text search index, and then you add and the ones that I have access to. If you're using Elastic and people have a few, each document has a few people, you can use an array, so it depends on the database, but yeah, absolutely, yeah. There's no limitation. Okay, thanks a lot. I really appreciate your time, and if you have any questions, I'm outside. Thank you.